Hello, fellow students, and welcome to the class. Today we are going to learn how to iterate over binary trees in the three different orders, in pre-order, in order, and post-order. So I'm going to share my screen with you. I'm going to share the whiteboard. And here we have three different trees. And look, we could have a pre-order iterator. And here, the algorithm, the process is, first we process the root, then we iterate over the left branch of the root, and then we iterate over the right branch of the root, right? So if we want to define the other different orders, the parts of the algorithm are very similar, but what changes is the order, right? So for instance, if we have in order, first we iterate over the left branch. So this is the first thing that we do. Then we process the root, and then we iterate over the right branch, right? And if we have post order, first we iterate over the left branch, then we iterate over the right branch, and then finally we process the root. So you don't even need to learn by heart these algorithms. What is important is to realize that the prefix in the name of the iterator gives a hint about in which position we process the root, right? So for instance, in pre-order, the root is the first thing to process. In order, the root is processed in the middle. And in post-order, the root is processed at the end, right? So just by the name of the iterator, you can, let's say, deduct the order of the different process that you need to carry out in the algorithms. Okay, so let's see an example. Let's see how it works. For instance, if we have pre-order, we will write here the nodes that we are visiting. So if we have pre-order, we start in the root of the tree, and the first thing is to process the root. So in this case, we will print the content of the root, right? Then we iterate over the left branch. So we go here, right? All of this is the left branch of the root. We go here, and the first step is to process the root again. So as we are in B now, we print B. Again, we process the left branch. Once that we finished with the root, we process the left branch, which is A again in this case, right? So we go here and we print A again. So we finish with this left branch and we go to the right, right? We come back to B. We already processed the root. We already iterated over the left branch. So now we need to iterate over the right branch. So we go to B, to this B, and we process the root. So we write the content of the root, which is B. We iterate over the left branch, right? So we come to the left branch, and again, we are in the root of the left branch, which is B, right? So we write another B. Now, we don't have left branch in B, we don't have right branch, so we come back to the root, to the other B in the root. And we have already processed the left branch. So we go to the right branch, we move here, and we process the root, which is A. In this case, again, we don't have left branch, we don't have right branch, so we go back to the root. And here, we have already finished because we have processed the root, we have processed the left branch, and we have processed the right branch. So again, we go back one step back, right, to the other root, to B. Here is the same. We have already processed the root, we have already processed the left branch, and we have already processed the right branch. So again, we go to the main root of the tree. In the main root, we have finished with the left part of the tree, and we need to go with the root and the left part, and we need to go to the right part of the tree. So we move to the right branch, right? We have already done this part and this other part in the root. So we go to the right branch, and again, we process the root, which is A in this case. We don't have left branch, so we processed the right branch. We move to A, and we process the root, which is A again. We iterate over the left branch, so we move to the root of the left branch, and we process the root, which is B in this case. When we are in B, we don't have left branch, we don't have right branch, so we go back to A. In A, we have already done the root, we have done the left branch, we don't have right branch, so we go back to A. In A, we don't have left branch, we have done the root, we have done the right branch, so we go back to the main root. And in the main root, we have already processed the root, which was the first element. We have processed the left branch, and we have processed the right branch. So we have finished already. So let's do the next one, the Inorder one, and let's see if it's different. Okay, so in order, we start always in the root of the tree, but now we don't process the root. We need to iterate before over the left branch. So we go to the left branch, we move to B, and again, we don't process the root yet. We need to iterate over the left branch. So we go to A. When we are in A, we go to iterate over the left branch, but we don't have, it is empty. So we process the root, which is A in this case. And then we need to iterate over the right branch, and we don't have right branch here in A. So we go back to the root, which is B. And here we already have done the left branch. Now we need to process the root, which is B. So we print the value of the root, which is B. And now we need to iterate over the right branch. So we move to the right branch, and first we need to iterate over the left branch. So we move again to the left branch here. Now we need to iterate over the left branch. We don't have left branch. We need to process the root, which is B. So we write B. And we need to iterate over the right branch, which we don't have here again. So we go again to the root. In B, we have already done the left branch, right? So we process the root, which is B again. And now, now we iterate over the right branch. So we move from B to A. Here, we need to iterate over the left branch of A, which we don't have. We need to process the root. So we add A to the path. And then we need to iterate over the right branch, which we don't have here. So we go back again to B. In B, we have finished already. We have done the left branch, we have done the root, and we have done the right branch. So we go back to the root of the left branch, which is B. In B, we are also done because we have done the left branch, we have done the root, and we have done the right branch. So we go to the main root of the tree. And now we have finished with the left branch of the main root, and we need to process the root, right? So we add A to the path. So we have done the first and the second steps of the algorithm, and we still need to iterate over the right branch. So we move to the right branch, to A, to the root of the right branch. Now we need to iterate over the left branch of A, but it is empty. It is empty, so we add A to the path. We process the root, we add A to the path, and we move to the right branch of A. When we are here in the right branch, we need to iterate over the left branch. So we move to B, and here in B, we don't have left branch, so we process the root, which is B. We move back to A, so now we have done already the left branch of A. We process the root, which is A. So we write the next one in the path. And then we iterate over the right branch, which doesn't exist here. So we move back to A. In A, we have done the left branch, we have done the right branch, and we have done the root. So we move back to the root of the tree, and in the root of the tree, we have already done the left branch, we have done the root, and we have done the right branch. So that's all. We have the 9 elements of the tree. Let's see post order, right? Let's see how is this iterator. So here, first, we need to iterate over the left branch. So we start in the root of the tree. We move to the left branch. Here, we need to move again to the left branch. And when we reach the leaf, we don't have left branch. So we would need to process the right branch. We don't have it neither, so we process the root, right? This is the last step to do in this iterator. So we process the root, or the leaf in this case, which is A, the root of this sub-branch, and we go back to B. In B, we are already done the left branch, so we need to move, right, to the right branch. We move to B. In B, first, each time that we arrive to a new node, we need to repeat the steps of the algorithm. In B, we iterate over the left branch. So we go to B, and here we don't have left branch, we don't have right branch, so we process the root, which is B. When we are done, we move back and we iterate. We have done the left branch already, so we iterate over the right branch. We move to A, we iterate over the left branch, we iterate over the right branch, and we process the root, right, which is A in this case. Here we have already done the left and the right branches, so we go back and we process this root, which is B. So we write B. Again, we go back and we have done the left branch, we have done the right branch, and then we process the root, which is B now. We go back to the main root of the tree, and we have done already the left branch. So we move to the right branch. Here in A, we need to process the left branch. We don't have it, so we iterate over the right branch. We go here to A. Here, we need to iterate over the left branch, so we go to B. And in B, we don't have left branch and we don't have right branch, so we process the root. We add B to the path. We go back, and in A, we don't have right branch, so we have already done the left, we have already done the right, so we process the root, which is A. Again, we go back to the root. We have done the left, that doesn't exist. We have done the right, so we add A to the path. Finally, we go to the main root of the tree. And we have done the left branch, we have done the right branch, so we add the main root of the tree to the path. Okay, so we have here 3 different iterations, one with each iterator. As you can see, all of them are different. So when you are done, what you can do to check if you have done it right is you can verify the correction of your solution, taking into account that the definition of these iterators is recursive. So that means that if you go here to this path, right? For instance, if you go to the preorder iterator, it means that the root will appear as the first element of the path. Then you will have the 5 elements of the left branch, and then you have the 3 elements of the right branch. But this definition is recursive. So that means that if you go, for instance, to the left branch, the first element will be the root of the left branch, right? So this will be the first element. Then you will have the left branch, and then you will have the elements on the right branch. And you can see this, right, for every branch. If you go here to this one, to the right branch, you have the root of the right branch, which is A. Then you have the left element, the left branch, which is empty, right? Here is empty. And then you have the right branch. So, okay, this one, I made a mistake here, right? Here it is, this part on the right is the right branch. So as you can verify, this is a preorder iterator. If you want to verify in order, it is exactly the same, but now the root is in the middle, right? So for instance, we will have 5 elements on the left. We have the root, and then we have the 3 elements of the right branch, right? And here we have the left branch. Again, the root of the left branch is in the middle because now we are in order. So the root is after the first element, that is the left branch, right? We have the root. Here we have the left branch, and here we have 3 elements of the right branch. And this definition is recursive, so we could take the right branch and it could be the same. We will have the root, the left subtree, and the right subtree. If we take the right subtree, it is exactly the same. We have the left branch, which is empty here at the left of the root. Then we have the root of the right branch, and then we have the right branch of the right branch. Again, if we go to the last iterator, now the root will appear at the end because it's post order. So the last thing that we do is to process the root, right? So the root will appear here. We have 3 elements of the right branch, and then we have the 5 elements of the left branch. And again, if we go, for instance, to the left branch, we have the root of the left branch, which is the last element. We have the right branch, and we have the left branch. And the same on the right branch. We have the root as the last element. We have the right branch, and the left branch is empty. So in this case, when you finish the iterators, you can always verify that you have done it in the right order. If it doesn't follow what is defined in the algorithm, in the description of the iterator, then it won't be correct. And also remember that this prefix is what gives the hint of the order in which we process the root. In the following days, we will continue doing the iterations over the other trees that we have here, where the elements are not repeated. So probably it will be easier to understand. So thank you very much for following the lecture today. As I mentioned before, in the following days, I will complete more examples of iterations over binary trees. And well, I hope that it's helpful for you to understand how these iterations are done. If you have any problem, any doubt, please don't hesitate to ask in the comments or by email. And thank you for coming. I will see you soon. Goodbye.